Okay. Functional isomerism of amines. Functional isomerism of amines. Amines exhibit amines exhibits functional isomerism functional isomerism, that is primary, secondary, secondary, and tertiary. Primary, secondary, and tertiary amines possess functional isomerism. Functional isomerism. Primary amines RNH2, secondary amines RNHR, tertiary amines RNR and R. Primary amines, secondary amines, and the tertiary amines contain the same molecular formula, but their functional group is different. So here only functional group is NH2. Here functional group is NH, and here functional group is N. So these three are the different functional group with the same molecular formula. The organic compound contain the same molecular formula. The organic compound contain the same molecular formula, but different functional group. But contain the different functional group is called the functional isomerism. Is it clear? Is it clear to all? The organic compound contains the same molecular formula. The organic compound contains the same molecular formula, but different different functional groups. That is primary amine, secondary amines, and tertiary amines itself has a functional isomerism. See the example of this category. Example, with four carbons or with three carbons, we can take with three carbons, n is greater than or equal to 3. Number of carbons, minimum number of carbons, is equal to 3, that is CS3 CH2 CH2 NH2. This is the primary amine, structure number 1, and structure number 2 CH3 NH CH2 CH3. This is secondary amine, and the third one N CH3 and CH3. This is tertiary amine. So primary amine, secondary amine, and tertiary amines are functional isomer. So here we called 1 and 2. The relation between 1 and 2 is functional isomerism. Functional isomerism. 1 and 3. 1 and 3 also functional isomers or functional isomerism. And 2 and 3. 2 and 3 also functional isomers, and the total phenomenon is called the functional isomerism. Is it clear, Amma? Is it clear to all, girls? Is it clear to all? Is it clear to all? Next isomerism is metamerism. Amines exhibit metamerism. So definition of metamerism is the organic compound contain the organic compounds the organic compound contains same molecular formula, same molecular formula, but different alkyl groups are, but different, different alkyl groups, different alkyl groups are attached to, different alkyl groups are attached to bivalent or polyvalent, or poly, different alkyl groups are attached to bivalent or polyvalent functional groups, bivalent or polyvalent functional groups are called metamers, and the phenomenon is known as, and the phenomenon is known as metamerism, and the phenomenon is known as metamerism. So see here, bivalent or a polyvalent functional group. What is meant by bivalent or polyvalent functional group? Bivalent means the functional group is attached to two alkyl groups. Two alkyl groups. That alkyl group may be equal or may not be equal. That is called the bivalent functional group. Example, either ROR. So this is a bivalent functional group. Next, RNHR. So this also bivalent functional group. Next, thioethers, RSR. So this is also bivalent functional group. Next, ketones. Ketones also bivalent functional groups, RC double bond OR, bivalent functional group. Next, esters, RC double bond OR. So these are the bivalent functional group. Okay, now next, either amines, thioethers, ketones, and esters. So these are the best example for the bivalent, and polyvalent is R, N, R and R. This is called the polyvalent functional group. The functional group is attached to same alkyl group or a different alkyl group. Then it is called a bivalent or a polyvalent functional group, and the compounds are called the metamers. We will get the different compounds. That compounds are metamers, and the phenomenon is known as the metamerism. So in this case, we are discussing the amine. Okay, now organic compound containing nitrogen, amines topic. So we go through the amines examples. Example number 1: N is greater than or equal to 4. N is greater than or equal to N is equal to 3. It's not possible to write the metamer. Okay, N is greater than or equal to 4. So see the example: CS3, CH2, CH2, NH, CS3. This is structure 1 with N is equal to 4. Okay, N represents the number of carbons. The same compound I'm writing like this here: CS3, CH2, NH, CH2, CS3. Okay, now so 1 and 2 are called the metamers. 1 and 2 are called 1 and 2 are called metamers. 1 and 2 are called metamers. Okay, now 1 and 2 are called the metamers. Right. So one more example: if we take N is equal to 5 carbons. So how do you see here? Here the two alkyl groups are different. Here propyl group is there. Here ethyl. Okay, methyl group. And here ethyl and ethyl. The IUPAC's name is not equal. The bivalent functional group is attached to the different alkyl groups. While exchanging the CH2 group from left to the right, we will get the CH3 CH2 and the CH2 CH3. So this two relation is called the metamerism. Got it, Amo? Are you following me, girls? Are you following me? Is it clear to all? So next, Next one is next example. For example, if you take n is equal to 5 carbons, n is greater than or equal to 5, n is greater than or equal to 5. See here, CS3, otherwise n is equal to 5, I am taking n is equal to 5. CS3, CH2, CH2, NH, CH2, CH3. So total number of carbons is equal to 5 here. Next, if I change the alkyl group, okay, now so here 3 here 2, 3 plus 2, total 5. So here CS3, CH2, 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 NH, CH3. So 1 and 2 are called metamers. 1 and 2 are called metamers. So how do you say it is metamers? Based on the IUPAC nomenclature. Based on the IUPAC nomenclature. So name of this compound is N-ethyl propanamine. N-ethyl propanamine, and compound name is N-methyl butanamine. N-methyl butanamine and N-methyl, okay now, N-ethyl propanamine. Got it? Is it clear? So amines possess the metamerism. The bivalent or a polyvalent functional group is attached to the different alkyl group, so that we will get the different type of the compounds. Those compounds are called the metamers, and the phenomenon is known as the metamerism. Clear, Amma? Is it clear to all, girls? Is it clear to all? Next, last one is optical isomerism. Optical isomerism. Optical isomerism. First one, to exhibit the optical isomerism, carbon contains four different groups or atoms. Four different groups or atoms. Optical isomerism is a category of stereoisomerism. It is a category of stereoisomerism. Three-dimensional isomerism with reference to the space. Optical, geometrical, and the conformation. These three are under category of the stereo. To exhibit the optical isomerism, first condition is the carbon contains four different groups or atoms. Then that compound rotate the plane polarized light toward the clockwise direction or a anti-clockwise direction. See here, carbon contains four different groups. In the four different groups, I take the NH2 because we are discussing here nitrogen compounds. NH2, and let us take here methyl group, and here ethyl group, and here hydrogen. So this is the atom, these three are the groups. Now this carbon is called the chiral carbon. The valencies of carbon is NH2, CS3, C2H5 and hydrogen. Valency of the carbon is 4, and here valencies are NH2, NH3, C2H5 and hydrogen. So this central atom is a carbon. This carbon is called the chiral carbon, otherwise a chiral center. It is also called the chiral center, and it is also called stereogenic center, stereogenic center, or asymmetric center. Right. So now this compound, the compound of this solution, keep in a polarimeter. Keep in a polarimeter and send the plane polarized light. Plane polarized light means the light contains the single wavelength. Monochromatic light. It is simply monochromatic light. White light is a multichromatic light. It can propagate in all directions. It contains all wavelengths. That is called the multichromatic light. But monochromatic light or a plain polarized light contain only one wavelength light. It can propagate. Propagate is moving. It can propagate in only single direction. When a plain polarized light is passed through the chiral carbon compounds, these compounds rotate the plane polarized light. So plane polarized lights are usually show like this. Plane polarized lights are show like this. This is a plane polarized light PPL, and the test tube. The test tube contain the this compound organic solution. That is, let us take this compound. Right, organic solution. So when the plane polarized light is passed through this organic solution, this light will rotate by the compound. This light will rotate it by the clockwise direction. This is clockwise direction or anti-clockwise direction. So clockwise direction like this, anti-clockwise direction, like with the same quantity. Right. So this compound is called the optically active compound. So when NH2 group, primary amine functional group is attached to the chiral center, that compound exhibit the optical isomerism. See here NH2, CH3, C2H5, and here H. Keep a mirror here, then you will get another compound CH2, CH3, C2H5, H. So compound 1 and compound 2 both are optically active isomers. So these two compounds are called, this is a mirror image. So non-superimposable mirror images. Non-superimposable mirror images are called enantiomers. So structure 1 and structure 2 both are enantiomers. Both rotate the plane polarized light in a opposite direction. So let us take here 1 because atomic number is 7 here. 1 and this is 2, this is 3. 1, 2, 3. Right. It rotates the clockwise direction. This compound is a D compound. And this compound rotates the anti-clockwise. This compound is L compound. So D and L is called the racemic mixture. 50-50%. 50-50% of the D and L is called the racemic mixture. So this word we can use in SN1 mechanism. In SN1 mechanism, racemic mixture is formed. 50% D compound, 50% L compound. That is 50-50%. 1 and 2 are called the enantiomers. These two are optically active. 50% this compound, 50% this compound, keep in a polarimeter and send the plane polarized notch in the rotation of the light because external compensation. One rotate right side, one rotate left side. So both get cancelled and finally notch in the direction of the light. If you take only this compound, it rotate the right side direction. If you take only this compound, rotate the left side direction. Okay. So, but if you take a 50-50%, then resultant rotation is 0, then no change in the direction of the light. Is it clear, ma? Are you following me? Yes, are you following me? Girls, are you following me? Yeah. So this is called the optic, optical isomerism exhibited by the primary amines. Okay, now. Okay, tomorrow we will continue. Girls, tomorrow we will continue. Don't disturb the class. ఎవరికి కూడా ఈ లింక్స్ అనేవి షేర్ చేయొద్దు, ఇన్ఫర్మేషన్ పాస్ చేయండి అది. ఓకేనా? సో టుమారో సేమ్ టైం we will continue. Bye.